Hey there, Grade 7 Explorers, and welcome to this explainer. I want you to lean in and get ready because we're heading out on an epic expedition into the wild, invisible, and totally fascinating world of energy. As you prep for your exams, I want you to think of this not just as a regular study session, but as a safari through the ultimate habitat, our physical world. It's a place where power is constantly shifting, moving, and transforming all around us. All right, let's map out today's expedition so you can completely conquer your syllabus. We're going to cover useful and wasted energy, decoding Sankey diagrams, the national electricity grid, inside a power station, and finally, saving energy at home. Step 1 on our journey, useful and wasted energy. So our first stop brings us face to face with the everyday tools and appliances you have lying around your house. We're going to observe how energy behaves and transforms the exact moment we power them up. It is the ultimate mystery of the energy kingdom, right? Where does the energy go? When we switch on a system, energy is transferred from one object to another. But nature is a little messy, and energy doesn't always go exactly where we want it to. Think of it like this. Every system has an input energy and an output energy. The energy that actually does the job we want, that's our useful output. But then there's the energy that basically just escapes into the wild. We call this wasted energy. It's power that leaks into the surrounding environment, usually as heat or sound, completely failing to do the job we intended. It is kind of like a predator using up all its energy just roaring, instead of actually catching its prey. Moving right along to Section 2, Decoding Sankey diagrams. Now, we can actually track these energy footprints using a really cool scientific tool called a Sankey diagram. But before we even get into that, you absolutely have to understand the golden rule of this wilderness, the law of conservation of energy. Basically, energy cannot be created and it cannot be destroyed. It merely changes form. Because of this, when you're looking at a Sankey diagram, you'll see this magical mathematical balance. The total width of the input arrow always perfectly equals the combined width of the useful and wasted output arrows. Let's observe two different species of light bulbs in their natural habitat. On one side, you have the traditional incandescent bulb, the ones with the little metal wire inside. It uses electrical input energy, but it is terribly inefficient. It produces just a tiny sliver of useful light energy, while a massive amount of wasted heat energy just bleeds into the surrounding air. Now contrast that with the fluorescent bulb. It sends electricity through a gas-filled tube. It is highly efficient, producing lots of useful light and a much smaller trail of wasted heat. Get this, here is a thrilling documentary fact for your exams. These highly efficient fluorescent bulbs use about 75% less energy than those old-school traditional filament bulbs. Not only that, but they can survive up to 10 times longer in the wild. It is just a brilliant example of technological evolution. You can see the same concept with another noisy creature of the household, the electric drill. Think about the breakdown here. The input is electrical energy. The useful output? Well, that's the kinetic energy, the actual movement making the hole in the wall. But what about that incredibly loud screech and the super hot drill bit? That sound and heat are just wasted energy escaping into the environment, completely unhelpful to the task of drilling. All right, let's zoom out for Section 3, the National Electricity Grid. We've spent some time in the microhabitat of household tools. Now it is time to look at the massive, macro landscape of South Africa's electrical nervous system. Behold the national grid. This is a magnificent, sprawling network of cables that safely transports energy from giant power stations directly to the switch in your living room. Right now, this mighty grid is primarily fed by burning coal. But, just like any environment, things are changing. Because our coal supplies will eventually run out, the grid has to evolve. So the government is investing in new ways to capture energy directly from the wind and the sun. Which brings us to Section 4, inside a power station. Have you ever wondered how exactly that raw material is transformed into the invisible electricity that powers our entire lives? Well, let's venture deep into the belly of the beast and follow the life cycle of power. Step 1. Coal is transported into a fiery furnace where it's burned. Step 2. The intense heat from this fire boils water, transforming it into high-pressure steam. Step 3. This powerful steam rushes forward, spinning the massive, heavy blades of a turbine. Step 4. That spinning turbine is connected to a generator, where giant magnets rotate inside coils of wire, miraculously sparking electrical current to life. And finally, Step 5. A transformer adjusts the voltage so this immense power can safely travel across the power lines all the way to your home. Now listen up, because this is absolutely crucial for your exams. You need to memorize this map of energy transformations and know exactly where each magical shift takes place. In the furnace, the chemical potential energy of the coal becomes heat. As that steam rushes to the turbine, heat becomes kinetic energy. As the turbine spins the generator, kinetic energy morphs into electrical energy. And finally, from the generator to the transformer, that electricity is prepped to eventually become the light, sound, and heat we use every single day. It's just a stunning cascade of conservation in action. Finally, we reach Section 5, Saving Energy at Home. Having witnessed the incredible journey and the massive effort required to generate this power, we really have to bring our expedition back to where it all ends, your own living room. We need to talk about protecting this precious resource. Conserving energy isn't just a polite suggestion, it is literally vital for our survival in this modern habitat. Why? Well, first, electricity is incredibly expensive, so saving it protects your family's wallet. Second, since most of our power comes from coal, using less energy means burning less coal, which significantly reduces the harmful gases getting pumped into our atmosphere. And finally, when too many people draw on the grid at once, the whole beast gets overwhelmed. That leads to load shedding, power outages that leave us all sitting in the dark. So how do we actually do this? Let's break it down into actionable steps. There are brilliant energy-saving habits, and then there are highly wasteful dangers you must avoid. Wearing a warm sweater instead of running a space heater, that's a top-tier conservation move. Washing full loads in the machine instead of half-empty ones and opening the curtains to use natural sunshine, excellent habits. But leaving external lights on in broad daylight, boiling an entire kettle to the brim for just one tiny cup of tea, or leaving the oven on when there's literally no food inside, those are dangerous, wasteful behaviors that drain the grid and leak our precious energy right out into the wild. Think about it. We've tracked energy from its raw, ancient form in coal through the spinning turbines of a massive power station right to the glowing screen you're looking at this very moment. You are now totally equipped with the knowledge to ace your exams and master the grid. But, knowledge requires action. Take a look around at the energy flowing through your own home. The power to conserve is literally in your hands. So I leave you with this final critical question. What changes are you going to make to protect our energy habitat today?